Hello guys, welcome back. Alexandru from Code Square here, and welcome to the second episode of C++ journey. Last time we actually learned about what? We learned about how to write. Here's first program, how to print messages, okay, how to do basic tasks, for example, sum of two numbers, multiple arithmetic operations, and so on. So that's basically what we learned last time, and today we're going to progress with two new topics. The first one, we actually, I gave you some type of homework last time. Basically, we had this problem here, where we had to calculate the last digit of the sum of two numbers. And I give you a hint about the remainder. If you remember what the remainder is, basically, when we are doing 9 divided by 4, please remember again, in C++, the division is actually a whole number. When it's done between two integers. So here the result is actually 2. But if we took 9 module 4, basically this gives the remainder of the division of 9 to 4. And this, because 9 is actually 4 times 2 plus 1, the remainder is 1. So this is 1. Okay, so what this has to do with our situation here? How we are going to find the last digit of a number. So, actually, first topic of today. So, first topic, work with digits of a number. Okay? This is the first topic. How we are going to do this? So, I'll try to give you a little bit of a demonstration. This is basically a mathematical formula, I would say, but not really that technical. It's actually really easy to remember. So basically, let's say that we have a number, for example, 247, okay? So, I want you to please look at what the division does and what the remainder, basically the module operation, does. In our case, we want to extract this 7, okay? So this 7, right? Now, there is a little trick here. Do you remember from math subjects how we can write this number as basically a sum of powers of 10? For example, this 247, if you remember from the math lectures, when we had a number, for example, a, b, and c, and this could be written as a times 100 plus b times 10 plus c, all right? And that's basically the trick here. Basically, we can write 247 as 2 times 100 plus 4 times 10 plus this last 7. And you can see, yeah, 200 plus 40 plus 7. It's exactly our initial number. The main trick here now is that what all these numbers, or all these basically operators here, what have they in common? Well, it's the fact that they are all multiple of 10s. Okay, this 7 is also multiplied by 0 to the power of 10 to the power of 0, which is actually 1. Okay, so that's why we didn't write anything. But these are 2 times 10 to the power of 2 plus 4 times 10 to the power of 1 plus, of course, 7 times 10 to the power of 0. So, what's my idea? Is that this further can be written as 10 multiplied by, so what we did here, it's actually, we are trying to have a common factor here. So 10 multiplied by 2 times 10 plus 4. And we close the parentheses plus this last 7. So nice, okay. So this is 10 times something plus 7. And the really nice thing here is that now this way of writing this number, you can actually check, and this works. For example, 2 times 10 is 20, so this is 20, plus 4 is 24, times 10 is 240, and the plus 7 in the final is 247. Now, the main idea is that here, this equation, I mean, some type of the idea of an equation, actually looks very similar to the dividing formula. So basically we could say that 247 it's 10 times this 2 times 10 plus 4 plus 7. In other words, this 2 times 10 plus 4, it's actually 247 divided by 10. And this 7, it's 247, and because this is the division, this will be actually the remainder. So this is 247 module 10. And that's it. This is how we are finding out the 7. And actually, we can also take it more logically in some other way. For example, what if we had 247, okay, and we want to get this 7? Well, when we are doing the remainder, basically the division with 10, the last digit, it's actually what cannot be taken anymore, if you know what I mean. Because if we are doing the 247 divided by 10, we all know the rules. Basically, this is 2, 20, this is nothing, this is 4. We actually take down the 7, and this is 4. And now 40, nothing, 7. And this, because it's less than the 10, this is actually the remainder. So long story short, we are actually getting the last digit of a number by taking the module of 10. So let's do something. So the last digit of a number, it's for example x divide module 10. Now a really cool fact is that let me show you something. Let me open another program. It will be easier to scroll down. Okay, 1 second. Oh, okay, here. So if we had 247, let's say that we are going to do the classical division. Okay, so if we divide this by 10, but in the classical way, not in C++, this is going to be 24.7. Okay, but what do we know about division in C++ is that this 0.7 actually disappears because we don't have, when dividing two integers, we don't have this, we need an integer number. And we said that it's always the number without its decimal this is decimal variables, okay? So this is 24. But 24, it's actually the number without the last digit. So if we want to remove the last digit of a number, it's actually the number divided by 10. So if we need to get rid of the last digit of a number, we do it by it with 10. X divided by 10. Now, let's get this sum a little bit further. What do we know? For example, we have 3743 and we divide this by 100. Well, normally it will be 37.43, but without the decimals, we actually get 37. So if we need to remove the last two, we need to divide by 100, you guessed it, okay? So this goes on and so on. So this is 37. Okay? Now, if we need to get the last two digits, so not get rid of them, but get as a value the last two digits, for example, for 3749, if we actually do that now the module to 100, okay, this again is going to be divided by 100, divided, and we will be left with the first number that is actually less than 100, which is 49. So this equals 49. So if we want to get the last two digits of a number, do x module 100. Okay, so that's it. That's it. If you want to get rid of the last two, divide x by 100, and so on. If we want 3, we do the module 1000 and dividing by 1000. So no big deal. That's basically the lesson today. Okay. Now let's solve one or two problems with this. Starting with the first one, which was some homework. I don't know if you managed to get it alone. Congrats. I mean, you are amazing. If not, it's everything okay. We are here to learn, and you will have plenty of time to do this alone from today's lecture. Okay. So let's see this problem. We are given two numbers, x and y, and we need to calculate the last digit of their amount, basically of their sum. So now this should be easy. This should be easy because we'll have two numbers. Let's remember from last time, we need to declare it first. So how do you declare it? With int from integers, x and y. Okay, don't forget the semicolon. Now we need to read them. How? With c in. So c in greater x greater y. Now basically we read, we tell the user that he has to read from the console the two numbers and give to the program. And now we are going to do what? C out the sum of the two, so x plus y. And now a big mistake is to actually put module 10, basically to get the last digit. But the only problem is that the module operation, it has the same priority as multiplication and division. So the sum, the adding operation, it's actually less. It has less priority than the remainder, the module operation. So now we are going to get x plus the last digit of y, and that's not what we want. So in order to avoid that, we need to make sure that the sum is made first. So we are going to put x plus y in parentheses. Okay, so please don't forget to do that, and we should be good to go. Let's build this. 1 second. Sorry, we had a problem with the library, but now it should be all good. And let's see, 2578. Wow, nice, 3. Why? Because 25 plus 78, it's actually what? 3 and 1 in mind, and this is going to be what? 103. So that's amazing. That's amazing. We are going to have the 3 as the last digit. Let's get this code and upload this under the C++ coding language, okay? Great. Great. That was a nice start. That was a nice start. Good. Let's try to do another problem. And this one I will actually give the requirements here. I mean, probably there is a problem here in the list of problems, but I'm not going to start looking through it. I will just, yeah, build it on the way. So let's see. We're going to have the following problem. Given a number with exactly 4 digits. Basically, what does this tell us? Actually, no. Let me write the statement first. So, given a number with exactly 2 digits, that will be written from the console. Please output the sum of its digits. Okay. This problem is going to be really helpful to actually practice our fundamentals with working with a number of digits. Okay, so let's solve this. You can actually pause the video here and try to solve it yourself. Do some cases, try and test it, see if it works, and I'm going to wait for you. So good luck. I hope that you guys are back now. For those who think that they have a solution, congrats. Let's see if your solution actually looks like the one we are going to do now. So a number that has 4 digits. What does that mean? Well, what is the first number that has 4 digits? Well, it's actually 1 and then 0 0 0. So 1000. Okay, so this is the first number that has 4 digits, and the last one is, of course, 9999. Okay, so we have a number in exactly this interval. Okay, what do we have to do with it? Basically, calculate the sum of its digits, and let's do this. First, we have to declare the number. So, for example, x. We have to read it. Okay, it says that this will be written from the console. And now we actually have to start doing the sum of its digits. How? Well, in a really interesting way. Well, first let's have another variable named sum, initialized with 0. Okay, basically why? Because we don't want to do all of this in a single output, in a single cout, and get get dizzy by it. Okay, we want to take it step by step and see how do we extract each and every digit of the number. So how do we get the last digit? Let's see. How do we get the last digit? Well, the first one would actually be x module 10. Okay, so the remainder of x divided by 10. That will be the first, the last digit. So sum plus equal. Okay, I want to show you something. I don't know if I showed you last time, probably not. So there are 2 ways we can actually modify sum. We can say sum equals sum plus, I don't know, whatever, 10. Or there is another way for this. It's just a shortcut. we could say that it's a shortcut. We can say sum plus equals 10, and basically it's the same thing. This just tells us that we want to add 10 to the sum. Okay, so we are going to use this type of shortcuts a lot from now. Okay, so we have a lot of different shortcuts. For example, sum minus equals, I don't know, 7. This is again, we extract 7 from the sum. Or sum multiplied equals with 6. This is the multiplication operation. Or sum divided equal 3, for example. This is actually dividing the sum by 3. So please keep this in mind whenever you see this, know what it means and try to implement it in your own codes from now. Okay, let's get back to work. So we will say sum plus equals and the last digit of x, which is x module 10. Great, that's amazing. Now we actually, and we can actually also take a number as a reference. For example, 6,312. Now we actually took the 2. So the 2 is actually taken, it's in our sum. How do we are accessing the 1? And this is going to be really interesting. And we actually have 2 ways of doing it. The first one is actually related to what I said earlier, that if we want to actually get rid of some digit, the last digit actually, we need to divide the number by 10. What do I mean by that? Well, in this case, we can actually do x divided equals 10. Basically, we divide x by 10, and now our number, instead of being 6,312, is going to be 631. Okay, so after this line, the number actually, we get rid of the last digit of it. And now we actually can repeat this again. Sum plus equals to x module 10, because now x has another value. And now you guessed it, we can do this again. So we get rid again of the last digit. Okay, now it's actually becoming 63. And sum plus equals to x module 10. We divide again. Now the number becomes 6. And now sum plus equals to x. We can actually say x or x module 10. It doesn't matter because then our x will have only one digit at the end. And that's it. That's basically how we are going to get all the 4 digits. Let's test it. We are going to do cout, less, and sum. Okay? Let's do. If this works. Let's see if this works. Okay, so this is going to be 6,312. So for this we have 12. So 2 plus 1 is 3, plus 3 is 6, plus 6, it's actually 12. Nice. What about 1,000? Well, it's 1. 0 plus 0 plus 0 plus 1. What about 9,999? Well, it's 36 because 9 is 9 times 4 because we have 4 digits. So this actually works. So that's awesome. So this works. That's awesome. We can go further. Now, what about another way? Well, another way for this. So this is the first way. Okay, this is the first way. The second way would be to actually extract the digits without modifying x. First, we start the same. Sum plus equals to x module 10. Now, we need to get the 1. Basically, not the last one, but the one before it. So in order to do that, we can do sum plus x divided by 10. So this is the number, but without the last digit. And for this number, module 10. Also, because division and module have the same priority, it will be taken in order. So basically first it's is doing the division and then it's taking the remainder when divided by 10. So this is how we are going to take the 1 in here. For the next one, we are going to do sum plus equals x divided. We need to, so keep in mind, x has never changed now, okay? X has the same value, so we need to divide it by 100, okay? So to get rid of the last two, and then get the last one. So x divided by 100 module 10. And the last one, sum plus equals to x divided by, you guessed it, 1000 module 10. And this will work as well. The only advantage to this is that we will have x with the same value. Okay, after. By the way, what if we needed to use x after this this part of our program? For example, x has to be used in some other operations here. With this solution it works, okay? Because we actually protected x from being modified. But what if we used this code, the one above it? For example, we want to print x times 10, but the initial x, okay? So cout x. So actually, let's do something something even funnier. X has the sum of its digits and then sum. Okay, so we actually printed the message, and let's see what this does. Now we have 6215. It says that 6 has the sum of its digits 14. And that's simply not right, okay? Why? Well, the 14 is actually the sum of 6215, but 6 is not the initial x. Why? Because it was modified. So how can we actually do this? How can we remember it? Besides trying to not modify it at all. Why? Because sometimes we actually need to modify it. We cannot do everything without modifying a variable. And a simple solution for this, and please keep this in mind because it's a really nice tweak at the beginner level, we just make a copy of it. So basically we do a int x copy equals x. And the funny part is that after we did the work with our x and modified it and so on, we can do x now becomes x copy. So we remembered the value of our x in another variable named x copy, and then after destroying and using our x, we restore its value by putting the value from x copy back to x. And now this is going to work like a charm. Okay, so now 6215 is going to be a really, really nice output. Exactly what we wanted. Okay, so that's amazing. That's really nice. Now you know how to work with digits of the number. This topic took longer than expected, so we are going to do a separate episode with the next topic. Next time we are going to learn about conditionals, basically making the program to take decisions. I will give you an example. Let's say that we have a child, and he had taken a test on maths, I don't know, and if his grade is bigger than 5, we should print the message, oh, you passed, or if it's less than 5, we need to print the message, oh, unfortunately you failed. So how do we do that? Because until now it's actually a code that has to be run line by line. So how can we actually make and print a message, but conditioned by something? This is what we are going to learn the next time, guys. Thank you for watching. I know that we are, again, at the starting of this channel. Hopefully, I really hope that we can build a community um, based on programming, and see you soon, guys. Take care. Bye bye. Alex out.